Okay, we're doing chapter 2.2 in the Math 10-3 workbook. This we're looking at metric units for length. This again should be a review from elementary, junior high, but we're going through that. So it's an important part of the 10-3 curriculum. Converting in between metric and imperial is a big part. Not just, we won't be just doing length, but we'll be doing area, volume, capacity, mass, all of those conversions, which you may not have done all of those. Try these. That's just some skills that will help you within this chapter. These I'd like you to do without a calculator. So remember, if you're multiplying by a power of 10, you look at what the exponent on 10 is, or how many zeros there are. If you're multiplying, you move the decimal to the right. If you're dividing, you move the decimal to the left. So they've kind of separated these into columns. So here 1.56, we multiply by 10, so that'll be 15.6. Decimal moves 1 to the right. 2 to the right means we have to fill in with a 0, right? Because there weren't 2 decimals. So that's 54,590. Here, 3 to the right gives us 125. Dividing by 10, we're moving the decimal 1 to the left, so 7.534. Here, 2 to the left, 8.975. Here, 3 to the left, 1, 2, 3. And fill in. Okay, so this metric is really called the SI, System International de Units. I'm not a French speaker, so pardon my accent, bad accent. It was developed in France. In Europe, it's known as the metric system. The system developed in France in 1791 to standardize all types of measurements around the world. So in Canada, when I was young, before, when I was first little, it was imperial that we used all the time. And then Canada adopted the metric or SI system, as do many of the European countries. The United States still goes by imperial. So because we're so close to the United States, we still think and use imperial quite frequently, especially in building. And so that's why we still have to know both. But metric is actually a lot easier just because of the fact that it deals with powers of 10 and decimals. So here are all of the units of linear measurement, the units of length for metric. The ones that are most common, kilometer or kilometer, you can say it either way. So we use that when you're driving. Meter, that's for shorter distances, but still frequently. That's kind of equivalent, close to a yard in imperial. This is similar to a measurement for miles in imperial. Centimeter we use a lot, and we also use millimeter. So really there's 4 that we use most frequently. In imperial we really use inches, feet. I guess there's 4, but they're not quite. Like inch is sort of closer to centimeter. So there isn't really something for foot that we use in metric. In any case, everything really is compared to a meter. So you can see here that 1 kilometer is 1,000 meters, hectometer is 100 meters, decameter is 10. And then obviously these are less than a meter, so they'll be decimal forms. So 0.1 of a meter is a decimeter. So a lot of times people get these mixed up, right? Deca and deci. So think of centimeter with an I. So these are close together. But you will have a formula sheet or a conversion page. If you take a look at your workbook, the last page, I will show it to you. It should look something like this. It's either inside the back cover or the front cover. Kind of depends on when they publish the book. So you'll see charts and formulas. So here, these are all the metric charts, and we're concentrating on length. So there's kilometer, hectometer, decameter, meter. So these are all what was listed in our section 2.2. And then imperial, so all the length lines up vertically. We already did this in section 2.1 of the workbook. And then we will look at converting imperial to metric and then metric to imperial. Okay, and then all in the first one. And then there's some formulas down here that we'll look at as we go through the workbook. Okay, so another important thing to remember is, so these have basically three lines, right? So this is the smallest, this is the biggest, so it's going in the chart from biggest to smallest. So here, if we wanted to convert, actually, I'm going to just erase this. If we wanted to convert kilometers to meters or centimeters or millimeters, we'd be going down, okay? And as we go down, we're going to multiply by some power of 10. Put a little box there. So that's my multiplication symbol by 10 to the something. Each line in this chart represents a power of 10. So if I was going down one line, I multiply by 10. If I'm going down three lines, I'm going to multiply by 1,000, 10 cubed. Here, from a meter to a millimeter, 10 cubed. Okay? If I'm going upwards this way, then I would be dividing by a power of 10. Okay? So just be aware of that. A kilometer is really big, so there's lots of millimeters in it. So the number of millimeters will be a big number. So you have to make a small number representing the kilometers bigger. So since this measurement system uses base 10, the same as our number system, measurements are expressed as decimals. Circle the larger unit in each pair. So you can just look at the chart. As I said, the largest is at the top. So if we compare centimeter with meter, meter is the largest unit. Millimeter with decimeter, decimeter is the largest unit. Hectometer with kilometer, kilometer is the larger unit. Decameter and centimeter, decameter is the largest unit. Okay. How many centimeters are in 5 meters? So 1 meter is 100 centimeters. So we have 5 of them. So 5 times 100. Pretty straightforward calculation. How many meters are in 8.5 kilometers? So just think about the logic. So a meter is smaller than a kilometer. So our number of kilometers in this is going to be a big number. So there's 1,000 meters in a kilometer. So for each kilometer, we have to multiply by 1,000. So that's going to move the decimal 3 to the right, so 8,500. Okay. Then example 1, Paula rides her bike to her friend's house, 4.5 kilometers away. She could also run, taking 1 meter strides. How many strides would she take? So really, we want to convert to how many meters. Okay, so will the number of meters be greater or less than the number of kilometers in this distance? So really, they're just talking about the number. So it's going to be greater, right? Because a kilometer is a big measurement. There's lots of meters in it. So it's going to be a greater number. That's a number symbol that I sometimes use to be quick. So 1,000 equals 1 kilometer equals 1,000 meters. How can you use this relationship to figure out the number of meters in 4.5? So we would multiply 4.5 times 1,000. Okay, So I'm just putting a colon there. That's what we would multiply. And so that would move the decimal, so that'd be 4,500. So if each stride is a meter, then that would be 4,500 strides. Okay. Here's just a little reflection. When converting between units in the SI system, the numbers do not change, but their place values does. And that's just because you're moving the decimal. Okay, here's an example of a ruler or tape measure that uses the metric system. You can see each numbered part is a centimeter. Then, so in here, this longer line is half a centimeter. And then each of the little lines is 1/10 of a centimeter, which is equal to a millimeter. Okay, example 2, the diameter of a loonie is about 26.5 millimeters. What is the measure in centimeters? So, will the number of centimeters be greater or less than? So remember, a centimeter is a bigger measurement, so it'll be a smaller, okay, a less than, smaller number. So what relationship can you use to express? So remember, there are 10 millimeters in 1 centimeter. You can see that from the ruler. So 1 millimeter is 1/10 of a centimeter. Okay, so you can think about either multiplying 26.5 millimeters by 1/10, okay, or that's the same as 26.5 divided by 10. Okay, either way, because really what you're doing here is you're dividing 10 into 26.5. The one doesn't change anything. So you're moving the decimal to the left, one space, one place value, so 2.65. This last chart here, they've actually mixed these up. So as you're going from millimeters to kilometers, your number is actually getting smaller. So this arrow should be this way. So maybe you can change that arrowhead. And we'll just X that out. And then this should be an arrowhead going this way. So in the description it says, when going from a smaller unit to a larger, so say millimeters to kilometers, the exponent on the power of 10 you multiply by equals the number of steps. Okay, it's really, this would be going from a larger unit to a smaller, because that's when you are multiplying. Okay, so you may not want to use that stair just because it kind of mixed it up in the workbook. But if we look at backwards, I'm trying to go back. Just give me a sec. There we go. Sorry. Here, you can follow this. As you go up, you're dividing. As you go down, you're multiplying. Okay, because that's, again, if you take a look at your back chart, that's how it's listed. So we would go down, just like in the chapter, you would multiply, go up, you would, go up, you would multiply, go down, you would divide. Okay. Actually, I just said that the wrong way. So here, you would, from a millimeter, you would divide to go up, multiply to go down. Divide to go up, multiply to go down. Okay, and then let's take a look here. Divide to go up, multiply to go down. Okay, so just remember that if that is helpful to you. And that's it. Okay, so